right. Hello. Good morning or evening, where you are. Uh, Martinator, how's it going? Yeah, so I think I mentioned a couple of times in the last couple of weeks that I was gonna do some extra streams, and I finally uh, was, uh, I think, in a good place to do that. So here we are. So today, doing a little bit of coding in the morning, as we do. Let's see here. Not working on that today. We're gonna be doing some backend coding, I think, on Glowing Telegram. So essentially, we've been in the process in the last couple of months of taking a lot of the processes that actually do I have Telegram running right now? Local host. So I'm still using this program on no, it's not running right now. On a regular basis to take my stream VODs and process them, and like doing silence detection and doing transcription and summarization. But we also re-implemented a lot of that work into stuff that happens behind the scenes in AWS. So I haven't really been using that yet. And so there are some obstacles that are standing in the way of actually being able to use the new stuff. Like, we don't have a front end that can really tie into the data that we're building. Also, I have a lot of local data, right? So the stream records and those sorts of things. Let me get Docker up. I see the API is down. That's why. The front end also, the proxy crashed. So I have a bunch of local data. Let's see. Let me pull up pgadmin. Of like, here's the streams that have happened. Here's all of the video files that have been processed. Here's the transcripts, all of those things, right? So what I'd like to do is take take the local data in Postgres and move it to where I want all of the data to eventually live, so we can start building APIs that are going to be hosted in AWS rather than having this API server that I built that I would have to run. I guess I could run Fargate, like Docker image, or I could run like EC2 and like a VM, like run a whole server basically continuously to serve this API. And I would much rather take a more quote unquote serverless approach, where I have some lambdas that serve the data, and have all the data in one place and have that in AWS, and kind of move in that direction. So there's a few obstacles, right? So we have a front end already that runs locally. We've last stream and the last couple of streams, I've been working on a new front end, kind of as a clean slate that is going to be then where I put in all the new work on some new things, and also eventually migrate the existing front end from Glowing Telegram into it and kind of consolidate. There's that front end needs to be able to talk to an API, which needs to exist in AWS, and then we need our data store. So there's a bunch of code that I've written that I'm not sure how much we will probably use some things, but I suspect that we won't need to necessarily recreate um, all of this existing code. Like right off the bat, first of all the code that we've written for serving, like being able to retrieve lists of the streams, getting individual streams, updating and deleting all of those things, they're all written to interface to Postgres, or at least to a relational database through Diesel, right? And we're not going to be doing that. We're going to be using DynamoDB. So there would be some substantial changes if we wanted to think about it in terms of taking the existing code and transforming it. I suspect that what we're going to land on is something that's going to be more potentially general purpose, where we can define one set of endpoints for deleting, creating, listing, retrieving records, regardless of the specifics of the table, the kind of records. So, but before we do that, I think what's going to make sense is to figure out how we're going to take the data that's in Postgres. So, as an example, we have an episodes table. So if I were to view this, here we have, here's all of the episodes that I've created through the glowing Telegram tool, right? So we have titles and descriptions with IDs, and then lots of metadata, like what stream the episode was from, our silence detection, or sorry, these are the time segments inside of the source stream that the episode was from, right? So like this episode was from about 327 seconds to 3,716 seconds in the stream video. And then there's also a render URI. This is less useful, as it turns out, but this was the name of the file that contained the rendered episode that got uploaded to YouTube. We have like an order index, so this is like the order of episodes in the playlist that ended up on YouTube. What else we got in here? Some status information, category, the video ID on YouTube that I started doing. So some of these have that and some of these don't. So I want to preserve all this data, right? I want to get this into DynamoDB so that the new front end and the new API will be able to will have all the data. So that's a little bit of context about what I want to do today. Here's all the streams going back to October 9th of 2023, which I guess is when I started putting data in here. All right, so all of that being said, reload, we have a extension update. All right, so the what I want to accomplish today, or like we can make some progress on it anyway. We'll see how far we get. I want to create a little Python script that's going to sync the data from Postgres to DynamoDB. Syncing here is important. This is going to be a one-way sync, right? We don't want to. Well, I don't care about getting the data from DynamoDB and putting it back into Postgres. This is one way, but it does need to be able to be run multiple times. Let me add a note here. One way sync from Postgres to DynamoDB. I want to be able to run this multiple times because I'm still going to be using the tool locally, and why do I have an alert here? Okay, cool. Seems like every day one of those extensions needs to be updated. So I still want to be able to use the tool locally, but I want to, one, I want to be able to run the script multiple times and have it work. And then I want to be able to run it without deleting any existing data in DynamoDB. Here's a thought. Let me go log into AWS. AWS. Sorry. Console.aws. Here. I have lots of accounts, and I don't want to actually show you the list of all the different accounts I have. I do MFA too. All right, so here we go into AWS. So we have a table for a glowing telegram in DynamoDB that we started using. I think I just called it metadata table. And if we go and explore table items, there we go. So we can see this is where we're storing data as we're ingesting the individual video files from the stream. So this is one table, and I think what we're going to do is we're going to create a few different tables in DynamoDB to sync data. One of the other things we're going to do is that we do have this table, and I think it's going to make sense. I don't actually know. So let's see. So we have this table called video clips. And video clips has a bunch of data. But I think it may be the case that we don't need to migrate this data because all of the relevant information will be in the video files. Except for maybe... Right. So most of this stuff you can figure out by just looking at the video file. I don't believe this content type is correct, but whatever. Audio track count, audio bit rate, frame rate, height, width. All of this data came from using ffprobe on the actual underlying video file. One thing that's important here is that this list of video clips ties the individual video to a stream ID. And that's something that we're not doing here yet. Right, so we have the silence detection information, and we have our metadata about the video file, like so. And then we also have keyframes that we got. So let me check my notes. What was the plan here? So we wanted to have extract our information about our series. So we have that here in Postgres. That's the series table. Of which there's not a lot of data, right? Potentially, maybe it just makes sense to manually create this data, right? So maybe we won't even migrate this. Few enough, we can manually do that. And then streams table. So this is listing the individual streams, of which way too many to migrate manually. All right, and then my other note was need to match rows in the video clips table to records in DynamoDB. Update the DynamoDB record with the stream ID. And I think that makes sense. But maybe in addition to the stream ID, we might also want to grab the maybe not the duration, because we should have the duration in the metadata already, right there. But maybe the start time, because the start time represents this. Each of these video files is roughly 20 minutes long, right? So if the video file, like if the video file is from like an hour into the stream, then its start time will be like an hour. Because it represents the offset from where it starts. The offset of where that particular video segment was within the context of the stream. So let's say start time. And we'll have duration because that'll, like I said, be in the data, and I think everything else will be too. The key things here are going to be the stream ID, and we can keep the ID as well, I guess. Or I might use the title as the effectively the primary key for this. Actually, what did I do? Oh yeah, here we go. So the partition key for this table was this key, which is where it was stored in S3. I had a thought just now. So there are things in S3. There are MKV files in S3 that don't have records in DynamoDB because they were uploaded into S3 prior to like all this other stuff being created as just like an archive before I had like this DynamoDB table, before I had any automation to do anything. So a question is going to be, what happens if I do this data migration and then I go back and I trigger the code that ingests all of this metadata? I want to say, let's see, that's video ingester is the code for that, right? So what we do is that when we get our results, we do DynamoDB client put item. So the put item operation, remind me of your behavior. So put item creates an item, according to this. You can use put item, delete, update item, or delete item. It creates a new item. If an item with the same key already exists in the table, and it's replaced with the new item. Okay. So that is not great, because that would mean that if we had additional data that, like we've already migrated data. Well, okay, so two things. One, if we don't have the record in DynamoDB, but we have the record locally in Postgres, which we would, because we have a record for every video of every stream since they started using Glowing Telegram locally, but there wouldn't necessarily be a record in DynamoDB. So when we do the migration, we will create a record in DynamoDB, and it's going to have some of the elements, probably key, And then whatever we migrate, so stream ID and start time, right, were the things that I was thinking. So, but it wouldn't have metadata or audio or keyframes or silence. So like I think like if we look at the code for summarized transcription, are we doing the update to DynamoDB in here? Yeah, and we're doing update item. Okay, so can we just do update item everywhere? Yeah. If an item with a specified key does not exist, update item creates a new item. Otherwise, it modifies the existing item's attributes. Right. So that's what we're doing here. So I think that this needs to be updated to do an update item. Yeah. So let's take a look at both of these, and we'll change this. That will mean that because this is actually a really common circumstance, right? Where we have like, here's an old system, here's a new system. We want to synchronize data from old system to new system. New system's not actually ready to be used yet, but we want to like start migrating data. And we want to be able to, like, an example, like we're already doing a kind of migration, right? Every time I have the new system set up, I'm archiving my videos to S3. That triggers the new system here by running this code that creates the record in DynamoDB. But I still have the old system going, and I want to do this data replication, right, from old to new, while I'm still using the old system, because the new system isn't ready to assume all of the functions yet. So we need to make it so that this can tolerate, like, there already being data there that's migrated, and kind of merge them, rather than assuming that it kind of owns the responsibility of creating the record. So put item becomes update item, and then most everything else is the same. Well, not really. I think, are we using the same library in both of these places? One would hope. One would hope. AWS SDK, DynamoDB. Yeah. Yeah. So with where was that code? There it is. With put item. Actually, I'm kind of surprised. Oh, I see. Okay. The method being called item is kind of weird, right? It's misleading, right? So what we're doing here is we're populating all the keys and values to go to be attached to the newly created item. So this has to change, because what we want to say is, actually, that that could be fine. And then we have to, rather than simply saying, hey, here's these keys and values, we need to say, here is the update expression to specify how we want to populate fields. Okay. Um, have attribute that's not expression. That. Yeah, that's what I want. Update expression. Yep. Copilot can extrapolate, right? So we want to set metadata. Yeah. So the this should be fine. There would be a risk. So I guess maybe some. I'm not sure if this is actually strictly necessary. You can alias attribute names. I think this is only necessary, strictly speaking, if your key is a reserved word. Following are some use cases for using expression attribute names. To access an attribute whose name conflicts with DynamoDB reserved word, to create a placeholder for repeating occurrences of an attribute name and expression, prevent special characters and attribute name from being misinterpreted in an expression. Right? So, like if you have a key in your object called percentile, well, there's an it's a reserved word, so you can't use that. Let's see. I don't suppose we have a quick way of seeing what the reserved words are. Expression attribute names, reserved words. There we go. I found it. So if you need to use any of these things, you need to alias it. So is metadata? Nope. What about audio? That's unlikely. What about keyframes or silence? Key and keys, but not keyframes. And silence is pretty unlikely as a reserved word as well. Shard, share, shared, sort, show, signal, similar, size, skewed. Okay. So we don't need to alias any of the attribute names there. So then we just need to use expression attribute values. And this is not how you do this. I mean, Copilot tried, but I don't think that works. I think that I should be able to essentially take this, replace all of the items here. There we go. And then we just add a colon. There. All right. So that should make it so that we will try to, I mean, if a record already exists in the table for that key, we will update it. Otherwise, this will create the record, which is kind of misleading. for something, an operation called update item. If an item with specified key does not exist, update item creates a new item. Otherwise, it modifies existing item's attributes. I guess conceptually, you can think of this like it sees if an item with this key exists. If it doesn't, it creates an empty item that just has the key, and then it does the update. Otherwise, it finds the existing item and it does the update. So that is a thing. All right, which was not even part of the plan, but we need to do that, and we actually need to get that. Let's get a new branch called data migration, I guess. I have to remember how to do Pulumi stuff. It's been a little while. Pulumi up. No, this is not going to do anything. I have to do. I have to like build the Rust code first. Cargo build. Lots of complaints. There was nothing changed anyway. Also, new version of Pulumi. I guess where. I started using Biome in my other projects, and so I have the extension installed. But we're not using Biome in this repo. So. Was there something I was doing after cargo build? Yeah. No, I think I fixed that. I think I fixed that with summarized transcription. So there was a thing where oh, that was for release. Okay, so it was definitely an issue where the Lambda for summarized transcription was kind of large with all the debug symbols, and so this was necessary before I could do a deploy. I don't remember if that was something I did on stream or not, but it was complaining when I was trying to deploy at one point that the binary was too large. Okay, so this is going to update. No. So that we should have a change to the video ingester. Because we just made this change. So I would expect that we would see a deploy for the video ingester. See, that would be in target actually. Target bug video ingester. Today. Oh wait. So this one has a Docker file. This one is slightly different. Right. So let's go look at the Pulumi code and I can refresh my memory of how this is supposed to work. I think this one is supposed to be a Docker build that we push to ECR. And that's something I wanted to do for everything, but I just couldn't be bothered to do it because we had a bunch of additional lambdas. Yeah. Let's take a look at this. So, video ingester job. Right, we have job definition, have video ingester image tag, we have a repo. Okay, so I think I have to go into video ingester and we do some kind of Docker build. Oh, hey, look, there's the Docker login I'm gonna need. That's handy. Audio transcriber. Oh, Um, yeah, so I need to be at the top level. Docker build. I don't think the service name was something that was required anymore. Take a look at the Docker file. That's a leftover from other Docker images. Okay. At some point in the future, I will have this all scripted so that we can when code is pushed up or maybe a release is done in GitHub, it triggers something that builds the images and pushes things up so that I'm not doing this manually. And the same thing with triggering the Pulumi deploys. But it's kind of not so important when this is all kind of work that I am not directly using yet. We're done with that. Go back to AWS and let's go look at ECR. So we're pushing to this video ingester repo. It's been nearly 2 months since the last push. Time flies. Well, while we're waiting for things, maybe we can think about how we want to actually do some Python code. Let's just create folder, create file, pg2tdb. All right, so probably not going to be doing that. We're not going to have kind of a generic script. This is going to be we're just going to write out, take stuff from this table, put it into this table. Yeah, we're going to want both 3 and psychopg2. So this is our library for interfacing with Postgres, and this is our library for interfacing with AWS. We can connect to the database. There's probably TSN, connection factory, cursor factory. Okay, so localhost database. It's called Video Processing Project. That takes me back. That was the original Django project that I created back a year ago to kind of prototype things out. User is Postgres. Yeah. Password is, I think it's also Postgres. how would I know? I think it's also Postgres. I'm just gonna let Copilot write some code for me. Connect to the DynamoDB. That's funny. Print, please. Yeah. So now we have some code that will hopefully connect to Postgres that's running locally and dump out the list of tables, and that will be at least something somewhat useful. So if I run Python migration, let's see, source. Do I have a VN and activate? I probably still don't have yet. Pip install and go to 3. I had considered like making like a proper like Docker container, wrapping this, and then we could manage dependencies that way, either with requirements.txt or just, a pip command inside the Docker file and doing all that stuff. But I just figured it'd be easier. This has kind of a limited shelf life in terms of, eventually we're going to. I'm going to say something that is something that has not always been true, and in projects in the past and these sorts of things. Like I said, this kind of data migration thing between old solution and new solution is super common, and a thing that one might say at the beginning or in the middle for potentially a long time is that eventually this will go away, right? Because the old system will go away and the new thing will begin. But ultimately, this is my project, and so I should be able to not fall into the trap of having a project going on forever because what about this other use case that this other person or group or what have you cares about. Well, anyway, there are many stories that not going to share. Names will not be spoken. So we have a list of table names, so we can actually connect to Postgres. So that's good. That's the main thing I care about there. Probably what we should do is we should do like with like that. Copilot has decided that it's going to write some more code for me, and I guess we can kind of get a sense. Of course, there's a table called video metadata. There's a table called series. So yeah, that works. Ta-da! All right. So we can do stuff. Let's get back to we were trying to build a Docker image. That's right. Now, video ingester. There's a command. Yeah, there we go. Tag. And should be a push as well. Okay. So we built the Docker image that has our code changes in it. And now we've tagged it, and we're pushing it to ECR. And I just want this in place because at some point I have a backlog of videos locally that I want to upload to S3, and when that happens, it's going to like run that code that we modified. And I want to make sure the right code is in place so that I don't trash any migrated data. Um, so, what now? Well, let's talk about the streams table. So, uh, tables to migrate. Streams seems like the first logical choice. Because DynamoDB is not relational, there's not going to be any kind of like foreign key thing where, oh, we have to make sure the streams are in place, because when we upload the video clips or update them and refer to the stream records, we're going to get some kind of referential integrity issue. There's nothing like that, right? And generally speaking, you want to really be suspicious about doing things like having multiple tables. I think this is going to make sense because the life cycles of the data are a bit different. Like, we get the video files, but there's a separate step where we need to be able to figure out which video files belong to which stream. So I think having multiple tables here in DynamoDB will make sense. Because DynamoDB is a document database, you can see here in DynamoDB, this item has a bunch of nested data in it. So you want to think of it as like a document of sorts that has like a bunch of different related data that all goes together, rather than, for instance, what you might be inclined to do in a relational database is be like, okay, well, I have the video record that has, here's where it's stored, and some information about it. And then I might have a separate table that's all of the silence detection information, or in other records we have like the summarization and the transcription. Those might be separate tables, potentially. There's an inclination to do that anyway in a relational database, but doesn't really make sense in DynamoDB necessarily to do that. So the data that we want to pull from streams is going to be ID. What else? What else is in the streams? A bunch of stuff. I don't think we're going to need to necessarily migrate everything, thinking about it. So one of the things I see here in the streams table, there's like this transcription segments and silence segments. That's kind of equivalent to the data that we are storing at the individual video level. While that data could be migrated, eventually I don't think it's necessary. So we have a title, we have a description, we have a prefix. So the prefix is something that has to do with how I'm organizing locally the video files that are being recorded, but also effectively how we're storing things in DynamoDB as well. So we just have a date-based prefix. That's helpful for some automation that I have locally that looks in a folder for all of the recorded videos from OBS to ingest them into the series. I think I'll keep that. That's kind of, it is typically going to be something related to the stream date, which is also being captured here. But I think it makes sense to kind of have it as a separate thing. Maybe that will change over time. The speech audio URL, I don't think makes sense. We have a column called thumbnail URL. I've never used that. Is that true or not true? Let's see. Back to full screen. Oh no, okay. Yeah. So I have it because Twitch provides a thumbnail. um, that may or may not work. Okay, so I guess I'll keep it. Let's get back to the side view. Okay. You can imagine that could be useful if we want to like, yeah, okay, we'll keep it. Created that, updated that. I think these are still relevant columns to have. What is stream? Oh, right. Okay, so stream ID. Copilot suggestions interesting here. If I wanted to have some kind of soft delete mechanism, I might want a deleted at. Stream ID here. I'm gonna keep everything. I'm not going to try to think about renaming columns right now. So stream ID here represents the ID of the stream from like Twitch. That's why the next column is stream platform. Thinking that potentially the stream might happen in multiple, like I might have streamed to YouTube instead of Twitch. Duration is interesting. I guess I'll keep it. And series ID. Hey, Brainless. How's it going? Happy Thursday. And series ID is which series the stream is related to. Okay, so let's get a, it's going preparing a KT, which I am never happy to have to give. A KT. I'm just drawing a blank. Oh, knowledge transfer. Right. That makes sense. Don't you want to transfer knowledge, Brainless? Yeah, writing documentation, I guess, is not necessarily fun. I do not like talking on big groups. I see. So how are we going to do this this migration? So one thing to observe here is that there's just not a lot of data. So I think kind of a naive approach is going to be simplest. So streams, and then let's see, streams, and then fetch all. Or row and rows. Honestly, we don't even need that. We can just do this. Select all. Select star is probably a mistake. There we go. Feel much better about that. Yeah, sure. Let's let's take an approach where we just like pull all the data and then we write it. Now let's just look at the first 5 streams and see what we get, right? So we're just reading data out. There we go. So we have data. Just ignore that warning. So we have an array of objects. So there was no series ID. We have a stream date. We have no stream ID, no stream platform. Okay. So then we want to write the data to DynamoDB, right? Now, what are we going to call the table? Well, this one's called metadata table, something, something, something. I'll just leave this here for now, and we'll update it. And then Copilot's going to write some code. There you go. Yeah. So something like that. I think we'll want to massage that a little bit, but somehow an hour has gone by. So I'm going to take a break here for a couple of minutes. And we're going to come back, and we're going to actually write the rest of it.